In this lesson, I'm going to do a few mixed questions on arithmetic sequences and series. So I'm going to start with the first one here. Write the first three terms in each of the following sequence defined by the following rules. So the first one is 3n plus 2, n squared plus 1. So this is the mixed one. The first one is arithmetic, but the remaining ones are not. So it's just a quick recap on how do you find the terms when the rule is given. So one thing you can do is you can do it by hand. So you substitute for u1, you substitute replace n by 1 and you get 3 plus 2, which is equal to 5. And similarly, you can find u2 and u3. And then here also u1 will be 1 squared plus 1, which is 2. And then similarly, you can find u2 and u3. And here as well, u1 is equal to negative 1 to the power of 0, 2 to the power of 1, and then this is 2. So similarly, you can do the same steps to find u2 and u3 by substituting and replacing n by 2, you will give you u2, and substituting n by 3 gives you u3. I'm also going to show you how to do that using your calculator. So I'm not going to, when I'm going to input the rule, I'm going to replace n by x. So instead of 3n plus 2, I'm going to simply write down 3x plus 2. So the way you do is you go to y1 and then you substitute here 3x plus 2. And then you go to second window, which is your table set. Make sure that, because we want first three terms. So if they ask you to find the 10th term, then make sure your table start is at 10. But here they ask you to find first three terms, your table starts at 1. So now we go to second table and you can see the first value is 5. This is what we got here. The second value will be 8 and third will be 11. So 8 and 11. Similarly here for the second one, you have n squared plus 1. So I'm going to exit and then going to substitute here x square plus 1. And then again from table, you can see it's 2, 5 and 10. We already got 2 here. So this is 5, this is 10. And now the third one is, again, you change the function. And here you have negative 1 to the power of so for negative 1, you need to enter, let's use the bracket. So negative numbers, you need to use this key. So negative 1 to the power of x minus 1, and then 2 to the power of x. And then again, you go to second graph and it should take you, give you the number of the term value. So here the first is 2, the second one will be negative 4 and then 8. So this is how you can use actually calculator also to find the terms if the rule is given. Okay, the second one is a sequence is defined by for un is equal to, so un is equal to n cubed minus 6n squared plus 11n minus 6. And they want you to show that the first three terms of the sequence are 0 and all other terms are positive. So to show that, I can use the calculator, or you can substitute u1, which is 1 minus 6 plus 11 minus 6. The another thing which you can notice here is that the coefficient of, if coefficient of these with the constant term, which is 1, negative 6, 11, negative 6, which is what we got after substituting n is equal to 1, when you add them, this gives you 0, which also means that 1 is a factor of this cubic function. Now similarly for the second term, you need to show u2, which is if you substitute n by 2, then it should give you 0 also. So there is another way of doing as well. You can also use you can substitute here, so 2 cube minus 6 into 2 square plus 11 times 2 minus 6, and it will give you 0. Similarly for u3, it will also give you 0. And I'm also going to do one more time using calculator. So you can enter your given function, which is in this case is x cube. So you have x to the power of 3 and then minus 6x to the power of, 6x to the power of, no, it should not be there. So x cube and then negative 6x square, and then you have plus 11x minus 6. And then if you go to second table again, so you can see 0, 0, 0, and all other terms are positive here. So that's what they wanted you to find out. And here you can, because these first three terms are 0, which means 1, 2, and 3 is going to be a factor of this cubic function. And the remaining, when you start substituting the value which is greater than 3, that is 4, 5, and 6, all the values are going to be positive here. Okay, the next one is you have a sequence which is u1 is equal to 1, u2 is 1, and then you have un, which is un minus 1 plus un minus 2. This is the notation for all. So instead of writing for all, this is the notation we can also use for all. And then this is the rule or the relationship we have for n is greater than 2. This is a recursive rule. And what we need to do here is, from recursive rule, we need to find the ratio un plus 1 divided by un when n is 1, 2, 3, and 4. So I'm going to start with when n is equal to 1. So when n is equal to 1, your un plus 1 over un is going to be u2 divided by u1. So you substituted n by 1, and 1 plus 1 gives you 2. So u2 divided by u1. We already have u2 and u1, which means 1 divided by 1 gives me 1. So the ratio of un plus 1 divided by un for n is equal to 1 is 1. Similarly, for n is equal to 2, so you substitute, replace n by 2, which is u3 over u2. But we do not have u3 here. So the first thing we need to do is to find u3. The relationship is given, so we know un is equal to un minus 1 plus un minus 2, which means if I need u3, so I'm going to replace n by 3. So this becomes 3 minus 1, 2, 3 minus 2, 1. So u3 is u2 plus u1. And we have u1 and u2, so this is 1 plus 1. So u3 is 2. So once we know u3, u2 is already known. So the ratio u3 over u2 is going to be 2 divided by 1. So the final answer is 2 here. Similarly here, for n is equal to 3, we are looking for u4 divided by u3. We already have u3, but to find u4, again we need to use the relationship. And when we substitute here, n is equal to 4, we got u3, u2. So u3 we got was, from the previous one, we got u3 as 2. So 2 plus u2 is 1. So we got u4 is equal to 3, which means u4 divided by u3 gives you 3 divided by 2. So that is your final answer for this ratio. Now for n is equal to 4, you will have u5 divided by u4. Now we already have u4, which is 3. So I need to find u5. So again, use the relationship. So your u5 is going to be u4 plus u3. So u4 is 3, u3 is 2. So you get 3 plus 2, u5 is equal to 5. And then the ratio of u5 over u4 is going to be 5 divided by u4 is 3. So the answer is 5 divided by 3. The next question is, you have to show that this sequence is an arithmetic progression. AP means arithmetic progression. Find the 16th term and the general term. So I'm going to rewrite this again. So AP is given 9, 12, 15, 18, which means we know U1 is 9 and we know D is equal to, so you can see the difference is 3, common difference is 3, so D is 3. Now to find the 16th term and the general term, we know UN is U1 plus N minus 1 into D, which means this is equal to, you replace U1 and D by 9 and 3 respectively. So UN is equal to 9 plus 3N minus 3. So you got 3N plus 6. This is your UN. Once you have the general term, you can also find 16th term. So substitute or replace N by 16 and you will get your U16. So that's your 16th term. Okay. The next is, which term of the sequence -1, 3, 7, 11 is 95. So again, first thing is we need to recognize what kind of sequence we have. So by looking at this, I can see that there is a common difference of 4, which means it's an arithmetic progression. Now we know U1 is -1, and we don't know if this is the term of the sequence or not. And we don't know which term number is this. We know this is U1, we know this is U2, we know this is U3, and this is U4. But we don't know, first of all, if this is the term which belongs to the sequence, and if it does belong to the sequence, which term is this? So I'm going to assume here that this is UN. So if we have UN, so we are assuming that 95 is one of the terms of this sequence. So UN is U1 plus n minus 1 into D. So if I'm assuming this is one of the terms of the sequence, then I must get n as a whole number. If I get n as a whole number, it is a term of a sequence. If it's not, then this will not be the term of the sequence. So UN is 95, and then U1 is -1, and we have D, which is 4. So 95 plus 1 is n minus 1 into 4. 96 divided by 4 gives me n minus 1. So 96 divided by 4 is equal to 24. So we got 24 plus 1 is equal to n, which means n is 25, which means this 95 is a term of the sequence, and it is 25th term of this sequence. Okay, the next question is, forward value of n is the nth term of the following two arithmetic progression is same. So you need to find, do we have any value of n for which the term value will be the same for those two. So maybe it's like, somewhere here. So 25th term. So maybe 25th term of this sequence is same as 25th term of this sequence. And we need to find out if it's possible to have that in this case. And if it is, so for what value of n this is true. So we start with this. Both of them are in arithmetic progression. So U1 is 1. Here U1 is 69. Common difference in this case is 6. Here the common difference is -1. Now, here the general term is going to be U1 plus n minus 1 into D, which means 1 plus n minus 1 into 6. So 1 plus 6n minus 6, 6n minus 5. Here the general term is going to be U1 plus n minus 1 into D. So 69 n minus 1 into -1. So you will get here 69 minus n plus 1. So we get 70 minus n. Now, I don't know which term is going to be equal, if it is going to be equal. So let's say the nth term of those two are equal. If they are equal, so the nth term should be, both of them has to be equal. Now, if I simplify it, I got this as 6n plus n is 7n, and this is 75. So I got n as 75 over 7. So if we had a same term for both of them, then n has to be whole number. But in this case, we got n as a fraction, which means we will not have any term of these two arithmetic progression the same. Okay, if it will be a whole number, then it will be a same, but in this case we will not have them same. So the next question is, if the 8th term of an arithmetic progression is 31, so I'm going to write down, this is given arithmetic AP, 8th term means U8, and this is 31. So 8th term is 31, and the 15th term U15 is 16 more than the 11th term. So U11 more means plus 16. So these two conditions are given, and you have to find what is this arithmetic progression. Now we know that UN is equal to U1 plus n minus 1 into D, which means U8 is equal to U1 plus 7D, and U15 is equal to U1 plus 14D. And we also know U11 is U1 plus 10D. So I'm going to substitute all the values. So first thing I got is U1 plus 7D is 31. u1 plus 14d is equal to u1 plus 10d plus 16. So I got these values here. Now, from here, u1 get cancelled. So we got 14d minus 10d is equal to 16, which means 4d is 16 and d is equal to 4. Once we found the d, we substitute here. So u1 is equal to 3. So we got both the values here. And once we have both the values, we can write the sequence. So this is 7 and 10, 11, and then 15, and so on. So next one is, which term of the sequence is the first negative term? So you start with, and before you start, you need to again recognize what kind of sequence it is. So if you look at, there is a common difference of, so 19 1/4 minus 20 gives you negative 3/4. So the common difference is, in this case, is negative 3/4. Now we are looking for which term of this sequence is the first negative term, which means I don't know which one is it. So let's say un, and we are looking for when the term is less than 0. So I know un is u1 plus n minus 1 into d. So 20 plus n minus 1 into negative 3/4 less than 0. Now let's open the brackets. Plus 3/4 less than 0. I'm going to get rid of denominator. So this is 80 minus 3n plus 3 divided by 4 less than 0. So we got 83 minus 3n less than 0. So 83 is less than 3n. So 3n is greater than 83. 83/3, which is 27 2/3, which means n greater than equal to 28. So for n is equal to 28, 28th term will be the first term which is going to be negative in this case. You can verify, you can find the general formula, and then from there you can see that the 28th term will be the first term which is going to be negative. Okay, so next one is, if 5 times the 5th term of an AP, so it's an arithmetic progression, 5 times the 5th term is u5, 5 times means multiply by 5, is equal to 8 times its 8th term. So 8 times again multiply by 8, and 8th term is u8. So we need to set up this this problem. So 5 times the 5th term. So 5 times u5 is equal to 8 times u8. And you have to show that u13 is 0. This is what you have to show that. So let's start with 5 times u5 is u1 plus 4d. This is u1 plus 7d. So 5u1 plus 20d is equal to 8u1 plus 56d. And then we will get here 20d minus 5060 collect like terms. So you get 3u1 minus 60. So d 3060. So u1 is equal to negative 12d. Now, what is u13? It's u1 plus 12d. And u1 is negative 12d, which means your u13 is 0. Okay, so next one is, find the sum of first 20 terms of an arithmetic. So it's an arithmetic progression. You have to find S20. And in which third term? So u3 is 7, and 7th term, so u7 is 2 more than thrice of its third term. Thrice means 3 times. So 3 times u3 and then 2 more than, which means plus 2. So what is given here? The arithmetic progression. You have to find S20, and the condition is the third term is 7. So we have u3 is 7. And then the 7th term, u7, is 2 more than, so plus 2, thrice of its third term. So 3 times u3, and you have to find S20. So now that means u7 is equal to 3 times 7 plus 2. So we already know u7, and which is equal to u1 plus 60 is 23, and u1 plus 2d is 7, because u7 is u1 plus 60 and u3 is u1 plus 2d. So now you can simplify this by subtracting. You get 4d is equal to 16. So d is 4. Once you have d4, you can substitute in any of the equation. So u1 plus 8 is 7 and u1 is equal to -1. Once you have all the values, you can use the formula n over 2, 2u1, n minus 1 into d, and we have to find sum of 20 terms. So as 20 over 2, 2 times -1 plus 19 into 4. So you substitute all the values and then you will get here -2 plus 76, and whatever is your answer gives you as 20. Okay, the next one is, in an arithmetic progression, the sum of first n terms is 3n square. So you have Sn, which is 3n square over 2 plus 5n over 2. And you have to find its 25th term, which is u25. There are multiple ways of doing it, so I'm going to show you the easier way. I hope so. So what I can see here is n is common and then 2 is common. So what is remaining here? 3n plus 5. So I know the formula. There are two formulas, but I can use this maybe u1 plus un as 3n plus 5. So my u1 plus un is same as, if you compare them, should be 3n plus 5. And now I can find u1 using Sn, because S1 is same as u1. So which means here in this case, your S1 is 3 over 2 plus 5 over 2, which is your u1, which is 4. So once you have u1 as 4, your un is 3n plus 1. So you got your un, and then to find u25, you just substitute. So your u25 is 76. Okay, so the last question. Find the value of x for which 8x plus 4, 6x minus 2, and 2x plus 7 are in arithmetic progression. So 8x plus 4, 6x minus 2, and 2x plus 7, they are in AP. Now if they are these arithmetic progression, which means they should have a common difference of d. And how do we find the common difference? The common difference is u2 minus u1 and u3 minus u2. So I'm going to do that. 6x minus 2 minus 8x plus 4 must be equal to 2x plus 7 minus 6x minus 2. So 6x minus 2 minus 8x, open the bracket, plus 2. So you get minus 4x plus 9. And here you have minus 2x minus 6. So you get, by collecting like terms, so we got this, and x is equal to 15 over 2, 7 over 5. Oh, 15 over 2, 7.5, sorry. So this is your value of x. I also want to show you one thing. Whenever you have the terms in arithmetic progression, for example, 2, 4, 6, this is an arithmetic progression with a common difference of 2. If you notice that 4 is equal to 2 plus 6 over 2. So 4 is called arithmetic mean. Arithmetic mean. So here, because, and how do we get this? Because d is 4 minus 2, which is 6 minus 4. And if I collect 4 on one side, I can see that 2 times 4 is 6 plus 2. So my 4 is 6 plus 2 over 2. So you can also find the value of x by using that relationship. So if I generalize it, if you have a, b, c, then b is equal to a plus c over 2 is called arithmetic mean, or 2b is equal to a plus c. It's worth remembering this, this formula also, arithmetic mean. Okay, that's it for today's lesson.